Hello guys. So in this lecture we are going to talk about heap sort algorithm. Okay. So how a heap sort algorithm actually looks like. Okay. Let's just switch it. Yeah. So how a heap sort algorithm actually looks like. So we are going to talk about that. Okay. It is basically an algorithm which is used to sort a particular array. Okay. Sort a particular array. We can use it in order to sort a particular array, but it is mostly used in case of heap. Okay, so let's say we must know, I already told you that the prerequisite of this lecture is going to be uh, build max heap. Okay, build max heap. Okay, build max heap function, and the another prerequisite will be max-heapify function. Okay, and we are going to make some changes in these two functions in order to make it work with the heap sort. Okay, so what we are going to do within this max-heapify function, the function would be same. Okay, it would fix the violation, a single violation. Rather, we are going to use build heap to fix all the violations within the heap, and then we are going to uh, sort the array. Okay, sort the heap which is implemented in the form of array. Okay, so what changes we are going to do? We are going to implement it differently. Okay, so void build, let's say this is a build heap function. Okay, build max heap or build heap, whatever we call it. Inside this we are going to pass the array by we are already going to pass the array, and we are going to pass the size as well. Okay, and what we're going to do, we are going to start for loop from n minus 2 by 2. Okay, I is greater than equals to 0, and we reduce the build heap function each time, and we call max-heapify function. Okay, max-heapify function, but max-heapify function is also going to have parameters. So what parameters max-heapify function is going to have? It is going to have array as a parameter, it is going to have size as the parameter, but within the size, what we are going to do here is we're going to pass I here, and here we're going to pass uh, sorry, we are not going to pass I, rather it would be n only. Okay, and it would be I. Okay, so yeah, this build heap function would look something like this. Okay, let's increase it. Okay, yeah, so now, okay, now talking about the uh, max heapify function. Okay, max heapify function would also take, okay, so it is going to be void, okay, max heapify. It is going to take three parameters. First one is the array, second one is the size, and third one is the index. Okay, int I, the index on which of which we have to find the left and right. Okay, so first we'll find left is going to be, either you can write it this way, 2 into I plus 1, or you can write it left of I, because we have already written the the idea within this left function, right? So what we are going to simply do is left of I. Okay, this will give us the left index. Int R is going to give us the right index, right of I. Okay, right of I. Okay, and then what happens is that we are going to use the two if conditions. Okay, if L is less than, now the size is n. Okay, we are not going to write I here, size here. Okay, and ARR of L, if it is greater than ARR of largest. Okay, so I have forgot to write largest. So first let's write the largest. Okay, so largest variable would store I only. Okay, which is passed in the parameter. Okay, now if uh, you know if the left is less than size, which is n. Okay, which is passed n, and ARR of L is greater than ARR of largest, because okay, is greater than ARR of largest. Okay, in that case, what happens is that largest will store L. Okay, and okay, the second condition, if R is less than n and ARR of R, okay, is greater than ARR of largest. Okay, largest, then in that case, what happens is that largest will store R. Okay, and now finally, if the value of largest is changed from the initial value. Okay, if largest is not equal to I, which is the initial value, so we will swap ARR of I and ARR of largest. Okay, ARR of I and ARR of largest. Okay, largest. Okay, and we, after swapping these two values, okay, after swapping these two, what we are going to do is that we are going to call max-heapify function. Okay, max-heapify function, max-heapify. Okay, we are going to call ARR. Okay, then we are going to call N. Okay, and then we are going to call largest. Okay, for the next operation, max heap operation. Yeah, so this is how the max-heapify function looks like. Okay, let's reduce it. Okay, so this is how it looks like. And now talking about, okay, let's increment. Okay, now talking about the heap sort, what happens, let me write the algorithm here. Okay, let me write the algorithm, and we'll write the heap sort algorithm the next, we'll write the function in the next page. Okay, so talking about the algorithm. Okay, heap sort algorithm. Okay, heap sort algorithm. Okay, so what we are going to do, first build max heap. Okay, build a max heap. Okay, first the array we are given, we have to convert it into a max heap. Okay, second thing, we have, what we have to do is that repeatedly. Okay, what we have to do repeatedly, we have to swap the uh, you know first element, which will be ARR 0, obviously, right? ARR 0 with the last element. Okay, with last. Okay, with last element. Okay, reduce the size each time. Okay, after we have swapped the first element with the last element, reduce the size each time by 1. Okay, each time by 1, and call max-heapify. Okay, call max-heapify function. Okay, call max-heapify. Okay, now what I'm trying to tell you is, let's write the program now. Okay, so the let's move to the next page. So okay, sorry. So the program would look something like this. Okay, so we are going to call, okay, let me increase the size of the page. Yeah, let's move it a little bit. Yeah, so this is going to be a void function. Okay, void heap sort. Okay, we are going to pass array here. Okay, the implementation of the heap. Okay, and then we are going to pass the size. Okay, n. Now what you are going to do, we are going to call build heap, but we have, we have parameters now. Okay, so first we have array, then we have size. Okay, now repeatedly I said, so we'll run a loop from n minus 1. Okay, till n is greater than or equals to 1, and each time we'll reduce the value of I by 1. Okay, now what we'll do inside this, we are going to, I already told you, we are going to do two things. We will swap the first element with the last element is I. Okay, I will represent index, I will represent the value of the last element, ARR of I. Okay, and then what we'll do, we are simply going to we're going to call max-heapify function here. Okay, so let's erase it. Okay, we're going to call max-heapify function for the same array. Okay, we are going to reduce the size. So earlier it was n, but now it will become I, and I is equals to n minus 1, right? And we are going to call max-heapify function for the 0th element, because swap is we have swapped the 0th element of the heap. Okay, now let's try to look at the example. Okay, so let's talk about an example. Okay, now I already told you that you must know the prerequisite, that is build heap function and max-heapify function. Okay, so let's suppose we have an array like, we have a heap like this. Okay, so we have a heap like 3, then we have 7, 5. Okay, then we have 6. Okay, and 11. Okay, so this is the initial heap. Okay, there are violations in this heap. So after using build max heap, okay, build max heap function, what will happen is that, uh, after we call this function, we'll get a heap like this. Okay, so after implementing, for it, I equals to 1 and then I equals to 0, it runs for I equals to 1 and I equals to 0 only. Okay, from here it will run because it is having childs. Okay, this this value, this value at index 2 is not having any child, so it won't run from this. Okay, build max heap function is going to run for I equals to 1 and I equals to 0, and it is going to fix heap this way. Okay, for the first time what happens is that the value changes at this place. Okay, at this particular position. So 11 comes here, 6 is remains as it is, 7 goes here. Okay, and 3 and 5. Okay, now again, max-heapify is called for 7 for index 4 now, but since index 4 is not having any child, so it would terminate. Okay, I equals to 1, this is I equals to 0, this is I equals to 2. Okay, now a max-heapify function is called for the I equals to 2 within the build heap only. Okay, within the build heap only max-heapify function is called, and again what happens is that there is a swapping between these two nodes. Okay, because these 11 is the maximum between these three, right? So 11 is swapped with the root node. Okay, so what is the heap that we are going to get? We are going to get this heap. Okay, build only this function is running till now. Okay, only this function, build heap function. Okay, so we are going to get a new heap as 11, 3, 5, 6 and 7, and now the max heapify function is called for I equals to 1. Okay, for this. Okay, within this left and right of it and I equals to 1, the 7 is the maximum. So now after finally fixing the heap, okay, the final heap, final max heap we would say, okay, that we are going to get is 11, 7, 5, 6 and 3, and this is a perfect max heap. Okay, it follows all the properties of the max heap. Okay, such as that the node has the value greater than the child. Okay, so 11 is having value greater than 7 and 5, and this in this part 7 is having value greater than 6 and 3, which are the child of the node 7, right? So yeah, it follows the property of the max heap, hence it is a max heap. Okay, now we are done with this function. Okay, now this part occurs. Okay, so what happens is that for loop will run now. Okay, now for loop runs. Okay, so what happens is that, let's say the new heap is this one. Okay, now we see what is inside the for loop. Okay, so n is 5, right? So I will run from 4 till I is greater than equals to 1, and each time the value of I reduces by 1. Okay, now what happens is that we swap the first element with the last. Okay, so 11 is swapped with the last. Okay, so what happens, let's take the array. Okay, let's take the array. So let's say we have an array like this. Okay, so let me write the array implementation. Okay, so this is the array. Okay, initially we have this array. Okay, so let's move it a little bit. So after using the build heap operation, the array that we get is 11, this 11, 7, 5, 6, 3. Okay, 7, 5, 6, 3. Okay, now what happens is that for I equals to 4. Okay, first is for I equals to 4, right? In this for loop, what happens is that first we swap it with the last. Okay, ARR of 0 with ARR of I is 4 here, so ARR of 0 is going to get swapped with ARR of 4. Okay, so let's swap it. Okay, within this let's erase the value. So ARR of this is 0, right, and this is 4. Okay, let me write the index as well. 0, okay, yeah, 0, 1, 2, 3 and 4. Okay, so at the first index, we are going to get 3 here. Okay, at the last index we are going to get 11. Okay, these two are swapped. Okay, as you can see in the heap also, these two values, this and this. Okay, these two are swapped, and then what happens is that we are going to call max-heapify for index 0. Okay, so when we call max-heapify for index 0, okay, let's create this heap. Okay, let's create this heap right here. Okay, so this is the heap that we are going to get after we swap. Okay, after we swap, okay, it is going to have 3 here, then 7, then 5, then 6 and then 11. Okay, now when we call max-heapify function, we are going to give the size. Okay, size as I. Okay, here you can see the size we have passed as I, and the index we have passed as 0. Okay, so size is I is 4 here in the first case, so size will be 4. So we will call max-heapify for ARR array. Okay, the size will be passed as 4, and the index for which we have to call max-heapify function is 0. Okay, So we are going to call max-heapify for this I equals to 0. Okay, now this part has been removed. Okay, so it will remain as it is. Okay, here now we are going to only work with this part. Okay, yeah, this one. So what happens is that when we call max-heapify for I equals to 0, we'll see which one is the max in these three values. Okay, these three values. So 7 is the maximum, it is having index 1, right? So we will swap this thing. Okay, so the new heap that we are going to get, okay, the new heap that we are going to get is something like this. Okay, yeah, so what we are going to get is here we have 7, here we have 3, here we have 5, here we have 6. Okay, and now the max-heapify function is also called for this uh, for I equals to 1. Okay, earlier it was called for I equals to 0, now it will be called for I equals to 1. Okay, so you know these two values will be swapped as well, because 6 is greater than 3, right? And we are calling max-heapify. So what happens is that the final heap that we get is something like this. Okay, yeah, so 6 goes to the index 1, 3 goes to the index 3. Okay, 5 remains at index 2, and 7 remains at index 0. Okay, I equals to 0, I equals to 1, I equals to 2, and I equals to 3. Okay, now max-heapify function is also done. Okay, because now if you call max-heapify function for I equals to 3, it will have both left and right greater than the size. Okay, and the value of largest variable will not be changed. Okay, so yeah, a function terminates. Okay, now we are going to perform for I equals to 1. Okay, second time for loop will run from for I equals to 3. Okay, so for I equals to 3, ARR of 0 and ARR of 3 are going to be swapped. Okay, ARR of 3, so let's swap them. Okay, let's create the output array as well. Okay, so let's create the output array. Okay, so this is going to be the output array. So 1 2 3 4 and 5. Okay, so here we have 11 now. Okay, this is fixed. Okay, now after swapping ARR of 0 with ARR of 3, what we are going to get is this was the array, right? Let's create the array of this. Okay, this was the final heap that we obtained after performing min heap operation. So the array would look something like this. So 1 2 3 and 4. Okay, 0 1 2 and 3, 7 6 5 and 3. Okay, we will swap these two, these two values. Okay, so what happens is after swapping, okay, 3 comes to the first position and 7 goes here. Okay, so 7 goes at index 3. Okay, so this was 0 1 2 3 and 4. So 7 goes at index 3, 7 goes here. Okay, yeah, so now we will call max-heapify by reducing the size. Okay, so we will call max-heapify by passing the array. Okay, reducing the size to I is 3, and giving the index 0. Okay, we will call max-heapify for 0. Okay, so now the heap that we get is, okay, the heap that we are going to get is looks something like this. Okay, okay, after swapping, the heap looks something like this. Okay, this part is removed. Okay, this part is erased because we have reduced the size. Okay, we have reduced the size of the heap to 3, right? So yeah, now the heap looks something like this: 3 6 and 5. Okay, this is how the heap looks. Okay, and 7 is already inserted in the array, output array. Okay, now this is the array that we are going to get after performing heap sort. Okay, it would sort the array in the ascending order. How it is going to sort the array, we'll look at that. Okay, so we are going to call max-heapify. Okay, so this is I equals to 0, this is I equals to 1, this is I equals to 2. We are going to call max-heapify for I equals to 0 first. Okay, so it has size equals to 3. Okay, so in all of these, 6 has the greatest value and its index is 3. So largest will have index as 3. Okay, 1. Okay, now largest is not equal to the initial value 0 that we have passed in the max-heapify function, so swapping will happen between these two elements. Okay, 6 and 3. So the new heap will look something like this. Okay, so the new heap will look something like this. Okay, so here the element will have, there the value will be 6 3 and 5. Okay, this is the new heap. Okay, I equals to 0, I equals to 1, I equals to 2. Its array implementation would look something like this. Okay, let me create the array as well. Yeah, so let's say this is index 0, this is 1, this is 2. Okay, so this is at first 0th index it is 6, at second first index it is 3, and at second index it is 5. Okay, now what happens is that the heap is sorted. Okay, now again, now for max-heapify function is also performed. Okay, now we will see for the value of I equals to 2. Okay, so swap will happen between ARR of 0 and ARR of 2 this time. Okay, because I is 2, right? So let's swap. Okay, let's swap. Okay, so after swapping, what happens is that, okay, so 5 comes at the first place and 6 goes at the second place. Okay, and now we will call max heapify by reducing the size. Okay, so we pass array on itself and we give it the size as the I value of I, which is obviously 2 here. Okay, and then we call max-heapify for the 0 index. Okay, so let's first place the value of at the second index, so it will be 6. Okay, now the size has been reduced to 2. Okay, so now the heap would look something like this. Okay, so heap would look something like this: 6, sorry, 5 and 3. Okay, it would look something like this. Okay, and now when we call max heapify for I equals to 0, what happens is that it remains as it is because the value of 3 is less than 5. Okay, and now max heapify function is also done. Okay, for I equals to 2. Now the last case, for I equals to 1. Okay, what happens is that we are going to swap ARR of 0 with ARR of I, and since I is 1, we are going to swap ARR of 0 and ARR of 1. Okay, so let's swap them. This is I equals to 1, right? So after swapping, the array that we are going to get is going to look something like this: 0 1, there will be 3 and this will be 5. Okay, and the heap would look something like this. Okay, so let me create the heap as well. So at the 0th index it will be 3, at the first index it will be 5. Okay, yeah, and now we call max heapify function by passing array. Okay, by giving the size as 1. Okay, as I. Okay, and I is 1, so the size will be 1, and we are going to call max heapify function for I equals to 0. Okay, I equals to 1, and finally what happens is that the size, the elements will be allocated. So at I equals to 1 it was 5, right? Yeah, at I equals to 1, as you can see, the value was 5 at the end. Okay, now we reduce the size, so this node is also removed and we are only left with the one node. Okay, so even this one node is filled with 3. Okay, yeah, so this is how the array is sorted. Okay, now the output array, the heap is finally sorted and the elements are sorted in the increasing order. Okay, so this is 0 1 2 3 and 4, 3 5 6 7 and 11. This, all the elements are in the ascending order, right? 3 is the smallest, then 5, then 6, then 7 and then 11. So this is the output array that we are going to get. Okay, and what was the array that we passed in the input? So the array that we passed here is 3 7 5 6 11. Okay, let's write the input as well. Okay, input was something like this. Okay, okay, so the input was 3 7 5 6 11. Okay, let's try to implement it in the Visual Studio Code and let's see if it works or not. Okay, so we'll create another function. Okay, let me okay, heap sort we'll call it. Okay, yeah, so let's try to copy. Okay, let's try to copy this code. Okay, so heap sort, and let's, yeah, so now what we do is, let's say we remove all the functions except the insert function. Okay, except the insert function, and we are not going to even use it. Okay, yeah, we'll implement the insert function. First function that we're going to implement is max-heapify. Okay, max-heapify, and the second function that we are going to implement is build heap. Okay, again, and finally we are going to implement the heap sort function. Yeah, so let's move to, okay, this is build max heapify function and this is build heap function. Okay, let's move to max heapify function. Okay, void max heapify we call it. Okay, we are going to pass array here, we're going to pass the size, we're going to pass the index. Okay, now what we are going to do, we are going to make L and R variable equal to the left and right. Okay, so left of I, L will contain left of I. Okay, and R will contain right of I. Okay, now largest will have the value I only. Now we'll write two conditions. If left is less than n size, which is n, okay, in this case, and ARR of left is since it is a max heap, we'll use greater than sign. Largest, so largest becomes left, equals to left. Okay. Okay. Now if r is less than n, which is size obviously, and ARR of r is greater than ARR of largest, okay, then in that case largest remains r. Okay, largest becomes r. Okay, and if the value of largest is changed somewhere within the function, okay, if largest is not equals to the initial value which was passed in the function, okay, so this is the largest I. Okay, so what happens is that we swap ARR of I with ARR of largest. Okay, largest, and what we do is we call max-heapify function again. Okay, max-heapify function again, we pass the array. Okay, in place of size we pass the size, and we pass a largest in place of index. Okay, because that's what going to be fixed now. Okay, so this is the max-heapify function. Now I'll call build, we'll implement build heap function, void build heap. Okay, let's call it, yeah. Now we are going to pass array, okay, here int ARR. Okay, and then we are going to pass the size as well. Okay, so because we have to, yeah, so for loop, will run the for loop. Okay, for loop from n minus 2 divided by 2 to I is greater than equals to 0, and each time we reduce the value of I by 1. Okay, inside this we'll call max-heapify function. Okay, for ARR. Okay, then we'll pass I here. Okay, and we'll sorry, n and I. Okay, yeah, and now finally we are going to call Heapsort function. So void Heapsort. Okay. Okay, and ARR, so we'll pass the array, we'll pass the size, and we'll pass the index. No, we are not going to pass the index. Okay, so what happens is that first thing that we have to do, according to the algorithm that I told you, is we have to build a max heap, right? So build heap. This build heap is a build max heap function, but I have named it build heap only. Okay, inside this we have to pass the array, we have to pass the size. Okay, done. Now we have to run a for loop. Okay, for int I equals to from n minus 1 last index to index 1, and we have to reduce the value of I each time, and inside this we have to swap the first element ARR 0, which will obviously be ARR 0, to the ARR of I, last element. Okay, I will represent the last element, index of the last element, and then we are going to call max-heapify function. Okay, max-heapify function for array. Okay, we are going to give it the size as I, each time we reduce the size by 1. Okay, and then we are going to call max-heapify function for the 0th element. Okay, yeah, so this is going to be the total implementation of max-heapify Heapsort function. Okay, build max heap. Okay, so what I'll do, I have implemented it as build heap, right? So I'll call it build heap. Okay, yeah, and inside this we are going to pass array. Okay, and then we are going to pass n as the size. Okay, okay, array will be max heap dot ARR, right? And then size will be max heap dot size, like this. Okay, now initially it would be something like this. Okay, 3 7 5 6 11, but after let's call max heap function here. Okay, max heap dot heap sort function, not max heap function, heap sort. Okay, inside this we are going to pass max heap dot ARR, then max underscore heap dot size. Okay, and yeah, these two values. Okay, after calling max heap function, if we try to print it again, okay, it would be different. Okay, let's give a new line here. Okay, this is a new line. Okay, to move the execution to the new line. So this, once this is printed, then a new line is then the execution goes to the new line, and then this output of heap sort will be printed. Okay, so earlier we have this as the input, 3 7 5 6 11. Let's see, 3 7 5 6 11, and then after performing heap sort, we'll get 3 5 6 7 11. Okay, so we'll get the sorted heap array. Okay, yeah. So first we had 11 7 5 6 3. Okay, so what is, yeah, after performing build heap, right? Even we don't do this. Okay, let's see. Okay, yeah, so we had 3 7 5 6 11, 3 7 5 6 11. Okay, and the final array that we get after performing heap sort is 3 5 6 7 11. So all the elements are sorted, right, in the ascending order. So yeah, this is how the heap sort function works. I hope you understood the lecture, and I hope that it was easy implementation. Okay, so that was it for this lecture. Hope to see you in the next lecture.